Okay, so let's talk now about applications of these quadratic equations in section 1.7. This first problem has to do with, says the length of a rectangle is 2 feet less than 3 times the width. And then it gives you the area of the rectangle here is 40 square feet. And then it wants the dimensions of the rectangle. It's good to draw a picture in problems like this. So here I've drawn a picture of a rectangle, and I represented the width here as W, and then since the length is 2 feet less than 3 times the width, we're going to use 3W minus 2 to represent the length. So that's here. Now, we're given that the area of the rectangle is 40, but area is length times width, so that's equivalent to saying length times width is 40. This is an equation of 2 variables, so let's eliminate the length, or the L, by substituting this 3W minus 2 for it. So if we replace L with 3W minus 2, instead of LW, we get 3W minus 2 times W. And then we can distribute the W. W times 3W is 3W squared, and then W times minus 2 is minus 2W. And I hope this doesn't mess you up any, but I went ahead and moved the 40 across the equal sign as well. And so now I've got 3W squared minus 2W minus 40 equals 0. Now I could solve this with the quadratic formula, you know, the minus b plus or minus, all that jazz. But let's try factoring it. Let's try 3W and W. That's really the only factors of 3W squared that make sense. And then there's lots of factors of negative 40, but I tried a few, and I finally got the 10 here and the negative 4 here to work. And if you want to check it, let's do this. 3W times W is 3W squared. 10 times minus 4 is minus 40. And then we check the middle term. We do the outer product. 3W times minus 4 is minus 12W. And 10 times W is 10W. And minus 12W plus 10W is negative 2W. So I do have the right factors here. Now, the zero factor property tells me that for this product to equal 0, either the first factor, 3W plus 10, must equal 0, or the second factor, W minus 4, must equal 0. Well, if I set 3W plus 10 equal to 0 and solve it, then of course I would get 3W equals negative 10. And then when I divide both sides by 3, I get W equals negative 10/3. Well, it doesn't make much sense for W, for the width of a rectangle, to be negative, so let's throw that one away, okay? And let's go to this one. Here I have W minus 4 equals 0, so solving that would give me W equals 4 feet, and that one does make sense. So W is 4 feet, the width is 4 feet, and then all I have to do to get the length is go back up here and plug my 4 into here, and I get 3 times 4 minus 2, and you can see I have it right here, is 10 feet. So the dimensions of this rectangle are 4 feet by 10 feet. So the width is 4 feet, and the length is 10 feet. Okay, let's look at number 2. It says the rate of a corporate jet in calm air is 225 miles per hour. Flying with the wind, the plane can fly 1,000 miles in 1 hour less time than is required to make a return trip of 1,000 miles. Find the rate of the wind. Well, let's just do a little thing here. Let's say this is the starting point, and let's say over here is the end point. Okay, and let me just draw a graph here, a graphic here. Okay, so that's going to represent 1,000 miles. Alright, so that's going to be 1,000 miles. Now, let's say the plane, okay, here's a real pretty picture of a plane. Alright, there's the plane. Alright, now let's say the wind is blowing this way, and we'll call the wind, we'll call that rate, the rate of the wind, we'll call it X. Okay? So now, this plane here, if there's no wind, this plane will fly at a rate of 225 miles per hour. But with the wind pushing the plane will fly at a rate of 225 miles per hour plus the rate of the wind. So with the wind, the rate would be 225 plus x. Now, when the plane turns around and starts going the other way, the wind's going to be pushing against it. So therefore, it's going to be taking away from the rate of the jet in calm air. So when the plane's going this direction, then the wind's pushing against it. So it's going to slow the plane down, and so it's going to slow it down by whatever the rate the wind is. So when it flies back against the wind, it's going to go at a rate of 225 minus the rate of the wind. And by the way, you know, x is the rate of the wind. Now, the distance it's going to go to this destination, then it's going to return. So the distance is 1,000 on both ends of the trip. Now, time is actually distance divided by rate. So the time that it takes the plane to fly the trip with the wind is 1,000 over 225 plus x, 1,000 over the rate. So distance over rate. And then the time going back would be the same thing, but the rate changed. Instead of 225 plus x, it's 225 minus x. So that's the rate going back. So these are the times that it took. So the trip took 1,000 divided by 225 plus x to go this way, and then it took 1,000 times 225 minus x to go this way against the wind. Okay, so basically when it says that it can do it in 1 hour less time with the wind, it means that the difference of the two times has to be 1 hour. So I have to take the longer time, and this is where it gets tricky. I have to take the larger time minus the smaller time. Well, the larger time would be the time it took to go against the wind. So I would take 1,000 over 225 minus x. So I take the time against the wind, subtract the time it took with the wind, and that difference is going to be 1 hour. So that's going to equal 1. And so there's your initial equation. And now from that equation, once I get to that point, I can look at this and tell that the least common denominator is 225 plus x times 225 minus x. So I'm going to just kind of brush through this, but I'm going to multiply these three terms. There's three terms here. I'm going to multiply each of these terms by this lowest common denominator. So I'm going to multiply the first term by it, I'm going to multiply the second term by it, and I'm going to multiply the third term that's on the other side of the equal sign by it. Now, when I multiply this term by it, the 225 minus x's are going to cancel, and I'm going to have 1,000 times 225 plus x. When I multiply these terms by it, the 225 plus x is going to cancel, and I'm going to have 1,000 times 225 minus x. But there's a minus in front of that, right? So there's a minus there. So I have this. And then over here, I'm going to have the product of 225 plus x and 225 minus x. Now I had to grab my calculator. 225 times 1,000 is 225,000, and 1,000x is 1,000x. And then 225,000 times 1,000 is 225,000, but I have a minus, so it's a minus 225,000. I went ahead and just combined these two because this is 1,000x, and over here I'm going to have, you might want to work this out, but I have a minus and a minus, so that's actually going to be plus 1,000x. So I'm going to get 1,000x here, and I'm going to get a plus 1,000x here, and that's going to give me 2,000x. And then over here, 225 squared is 50,625, and x squared is x squared. So that's difference of squares, so I just get 50,625 minus x squared. Now, these guys cancel. That's the good news. Okay. Now, if I move these two terms to the other side of the equal sign, I get a positive x squared here. I get a minus 50,625 here, and I get 2,000x in the middle. Now, I just used the quadratic formula to solve this. You can use whatever you like, if you want to try to factor it, feel free to do so. But I just use the quadratic formula, and when I plug A, B, and C in the quadratic formula, you know, A being 1, B is 2,000, and C is negative 50,625, I got x equal 25 or x equal negative 2,025. Well, that didn't make sense for the speed of the wind, so the speed of the wind is 25 miles per hour. I'll let you just basically read number 3, and I'll just walk you through how I solved it. Area is 2 pi r squared by 2 pi r a, or plus 2 pi r h. That's the area of this can of coffee. And we're given that the area equals 188.5 square inches. So I just wrote this equation, 2 pi r squared plus 2 pi r h. H is 7 because it says that over here. And then that equals 188.5. And so that's 2 pi r squared, 14 pi r, and then I move this over and I get minus 188.5 equals 0. And then if you look at this, this is just a quadratic equation. A is 2 pi, B is 14 pi, and then C is negative 188.5. And so plug those three numbers into the quadratic formula, and the answer I got was a value of x that's very close to 3 inches. Actually, that's r. R for radius is very close to 3 inches. Okay, you can pause the video and read number 4 if you want. I'm going to go ahead and talk through it. You're basically over here, you're launching something up in the air at a rate of 20 meters per second, and obviously it's going to have to come back down eventually. And S represents the height of the object, and T represents time in seconds. So this represents the relationship between time and the height of the object. The first question says, when will the object be 15 meters above the ground? Well, for the object to be 15 meters above the ground, you just want to set S equal to 15. So basically, you want to put 15 in for S, and then solve this quadratic equation. So move the 15 in over here, and it becomes a minus 15. And then use the quadratic formula to solve it, and I get t equals 0.99 seconds, almost 1 second, and 3.09 or 3.1 seconds. So basically, let's say this level right here is 15 feet. Well, then it makes sense that it should hit that height twice, because it's going to hit 15 feet going up and it's going to hit 15 feet going down. So that makes sense. Now, when will it strike the ground? Well, if you can actually use the quadratic equation to solve this, or you can actually solve this by factoring a t out and solving it. But you can use the quadratic formula to solve it as well. But you'll find that your answer will be 4.1 seconds. So that's when it'll hit the ground. So it'll hit the ground, you know, when it comes back down, it'll hit the ground at 4.1 seconds. And then the next question says, when will the object reach a height of 100 meters? Well, you solve that just like you did A part, but you put 100 in. Okay? Now, if you do this, let me show you what's going to happen if you try to solve this. Let me pause the video for just a second, add something. Okay, so A is negative 4.9, B is 20, and C is negative 100. Let's go back to the discriminant real quick. B squared minus 4AC, well, 20 squared is 400, minus 4 times A, which is negative 4.9, times C, which is negative 100, and you're actually going to get 400 minus 2,450. So you're going to get a negative number for the discriminant. And remember, when you get a negative number for the discriminant, that tells you that there's no real solution. And the reason there's no real solution is because, based on this formula, it can never reach a height of 100 feet. And that pretty much sums up the applications that lead to quadratic equations. Have a great day.